Welcome to the Kernelcon outdoor smart plug flashing video. This is a Wyze plug outdoor. It's a dual socket outdoor rated smart plug. It has an ESP32 processor in it, so it's a little more powerful than the other smart plugs. This first video here will walk through how to take it apart, and we'll talk through some of the details of the flash process we're going to go through. So to get started, on the back there are 5 screws, and each of the screws is behind one of these little rubber plugs. So you can just take your screwdriver and pop them out, and they come out pretty easy. Then the next thing is these screws. They're not Phillips head, they're tri-wing, so they're shaped actually like a triangle. It's hard to see here, but you do need a special tri-wing screwdriver to get them out. So when you're working in the HHV, make sure you have one of these, or there are some that look a little different, but you can tell if you look at the end, they look like a 3-prong instead of a 4 like a Phillips. So then we'll just take the screws all out. They come out pretty easy, so we'll just take them out. Then we'll flip it over, collect our 5 screws. And then this little back cover, you can just kind of stick your screwdriver in the hole and pry it up a little, and then it'll pop off. And then it is connected by these weatherproof covers. So we'll just peel that off. So then this is what the inside of it looks like. And if you look carefully, I'll have a picture posted on the guide. But if you look down here, you can see there's labeled pins. GND for ground, TXD, RXD, there's one that's boot, and then there's one kind of hiding up in here that says 3v3. It's hard to see in the video, but like I said, I'll have a picture of it in the guide on the project page. So 3v3. So rather than trying to solder to all these little points and deal with that, we're going to use a special thing called a BDM frame. And I'll put a link to it in the guide as well, but basically what it is it's a piece of plexiglass with a bunch of holes in it, and it holds these tiny metal spring-loaded little fingers that we can just rest right on those solder points, and it'll let us connect to the chip without soldering. So let's talk about these pins for a minute. When you do this project, there are a number of BDM frames, and like I said, when you look at the chip itself, there are little solder points that are all labeled. And if you look at this programmer, I can't get it to focus, but I'll have a picture of this as well. But on the programmer, there are pins for 3v3, TX, RX, and ground. So these are all labeled as well, and the labels on these pins correspond to the labels on the smart plug. And if you look at these little adapters, they're all labeled 3.3 volts, TX, TXD, ground, boot, and RXD. Now, one detail that I want to share with you in advance is, like any other ESP8266 or ESP32, to be able to flash the CPU, we have to put it in bootloader mode, which means we have to have the boot pin connected to ground. So if we look at the top half of these pins, see this one right here says ground. And if you look, the ground pin loops through and comes over to the boot pin. So we can connect these 2 pins to our solder interface points, and they'll both be connected to ground, and we'll be able to flash that. Now, one other thing to note is when you're flashing an ESP32 or an ESP8266, the TX pin on the programmer needs to connect to the RX pin on the device itself. They need to be cross-connected. But to avoid any confusion, in this lab exercise, I have the probes labeled on one end TX, and on the other end they're labeled RX. So all you have to do in this exercise is follow the label. Connect this probe to RX and connect this wire to TX on the programmer, and everything will be fine. You don't have to worry about which is which. Everything is labeled very clearly to make things easier. So kind of put these over to the side. We'll grab the BDM frame. This will be a little hard to see, but the process goes like this, where you have the BDM frame, and we'll put our plug underneath. I'll make sure to post a bunch of pictures and some links to this as well. But then what we'll do is we'll take, for example, our 3.3 volt probe, we'll put it through a hole, and we will very carefully put the end of it on the 3.3V interface pad down below. And after we place it there, the frame will hold it in place. And as we're doing this, we should be taking our programmer and connecting 3.3 volt. Make sure to put it on the 3.3 volt pin. We'll put it right there. And in fact, we'll also take our programmer and get it plugged into our little extension lead. So we have a USB cable right here that's on a little switch, so we can turn our programmer on and off. So we'll just kind of sit it right here, and we can plug our programmer into it, so we're not jostling everything. There, it turned on, so I'm going to actually turn it back off. I don't want it on right now. I'm going to tuck it under this circle and kind of pinch it down. Right, so now I'll go ahead and connect my 3.3 volt pin to the 3.3 volt spot, and I'm going to pause the recording while I hit the rest of them, and I'll come back in one moment. Okay, so I got everything connected. Like I said, I'll have some better pictures of this close up, but you can see that we kind of have a few on one side over here, and we kind of have a few on the other side over there. We kind of put them on both sides and aim them at each other, so we have room for all the pins. Make sure that they get on each of the pins down below. The 3.3 volt one is a little bit difficult. It's this one up here. This power cord right here kind of gets in the way, so it might take a little wiggling. This is probably the one you'll have trouble with. If any of them don't line up and work, it's probably because of this. Now that we've got this connected, we'll look at flashing Tasmota on this device. So first thing we'll do is switch over to the other screen. So we'll go to tasmota.github.io/install, and we'll hit connect. And we'll pick our COM port. It's probably going to be something that looks a lot like this, CP2102. We'll hit connect. We'll see things connect. We'll hit install Tasmota. We'll select erase device, and we'll select next. Then we'll hit install. As long as everything is on the right points and everything is looking good, we'll see this message that says erasing. And then after erasing, we'll see this video, or this little graphic that says installing. It'll go through 4%, 5%, all the way up. So our flash did finish, and we'll see installation complete. Now that flash process will take 2 to 3 minutes, so don't be alarmed. As long as you see the progress indicator still going, everything's fine. So now we're going to click next, and now we're going to pause for a moment. Remember, we talked about that boot pin being tied to 0 to put us in bootloader mode. So when we did that, when we tied those pins together, it allowed us to flash code. So when we had these two pins tied together, we had ground and we had the boot pin tied together to ground. It put the device in bootloader mode. We've already done that now. So now we want to boot into regular mode. So what we're going to do is we're going to take this lead right here that says boot, just find the one labeled boot, and we're just going to very carefully pick it up and put it over here on the edge of the plastic where it's not touching anything metal. So it's completely out of the way. Then we're going to flip our switch and turn off our programmer, and we're going to turn it back on. And we're going to do this all very carefully without bumping any of the other pins. We want to leave them connected where they were. So now that we've got the plug flashed and we've got the boot pin moved out of the way, we'll refresh this page. We'll connect to our CP2102 again, hit connect. And now this menu looks different. We're going to do change Wi-Fi. So we've got the device running Tasmota. It's running our code that we trust, that we can audit, that runs locally without the cloud. We're going to onboard it onto our network. So here at the Kernelcon HHV, the network we're going to join is Kernelcon IoT, and the password is hackspace.io. So this is all in the guide. We're just going to paste that in right here and hit connect. It'll connect, so we hit continue, and now we're going to hit visit device. So this is the IP address of the device. You should make note of this, write it down, or make sure that you remember this is it. There may be multiple addresses in your browser history, so make sure that you remember that this particular address is yours for your outdoor plug. So the first thing we're going to do is, you can see we don't have any options to toggle the relays or do anything. It's because this Tasmota configuration, while the code is on here, we haven't configured it to actually control the components of the smart plug. So what we're going to do is we're going to go look at the hackspace.io/projects page, and we'll find the outdoor smart plug Wyze plug link right here. And when we go look at this page, we'll see that there is a template right here that we're going to grab. So we're going to copy this template, and then we're going to come back to our Tasmota interface, and we're going to go to configuration, configure other. We're going to remove all of this. We're going to paste that template in there, and then we're going to make sure to check this activate box, and then we're going to hit save. And it'll take a few seconds here. The smart plug will reboot, and this should reload. Then after the plug reboots, we see that our web interface is a bit different now. We have toggles for the relays. They're not going to work right now. You won't hear the relays click because the way it's set up right now, there isn't enough voltage to power them. But as long as you see the buttons here, then you know that everything is correct. This smart plug also does power monitoring, so we can configure that. There will be some notes coming soon on the Wyze plug page to optimize that. But there is one other command that we need to run here. So we're going to go to Tools, Console, and we're going to jump back over to the outdoor plug page. And if you look, there's a separate command here, Wi-Fi config 7. We need to run this. So when we configure this plug to join the Kernelcon network, it looks for the Kernelcon-IoT network. And if you take it home, obviously you won't have that. So this command, Wi-Fi config 7, you can read about it at the Tasmota website. I'll put a link to it out there. But what it does is it tells this plug, when you boot, if you try to connect to a network and you can't find one, broadcast an SSID so that someone can connect to it and reconfigure Wi-Fi without having to go through all the trouble of opening it up and doing all that work. So now we can go to Tools, go back to Main Menu, and at this point we are done. We are ready to reassemble and put this back together, and you can plug it into 110 volts and reconnect to this address and toggle the relays and use the device however you'd like.